So up to this point, we've looked at each cell of the design, and by that, remember, we've got this 6 cell where we have the levels of drink over here and the gender levels over here. And so we've looked at what's in each of these cells: women, no drinks; men, 4 drinks, and so on. But we can also look at larger groups of people. So we could look at all the men or all the women, right? So all of these people together and all these people together. Or we can look at the levels of drink, right? Just this row, this row, this row, okay? And the effect of each factor averaging over the other factor, this is called the main effect. So when you think about, okay, if we're comparing men versus women, right? So if this is men and this is women and this is no drinks, 2 drinks, and 4 drinks, right? If we're going to compare men versus women, but we average over the number of drinks, so we average over all these cells, and we compare men versus women, that's called the main effect. Or if we do the same thing, if we compare no drinks, 2 drinks, 4 drinks, by averaging over gender and compare them, then that's going to be the main effect for drink. Okay, so let's think about this visually. So if we look at this box plot, we've got men and women, right? So we got the men and we've got women over here. We've got each of their conditions, each of the drink conditions with the colors of blue, red, and green. So if we want to compare all the men, so averaging across all these conditions, to all the women, that would be the main effect. And then if we want to compare none versus 2 pints versus 4 pints, then we're going to average these two together, these two together, and these two together, and then we'll compare them there. And so that's going to be our main effects for gender and drinks. Okay. This is just another way of thinking about, this is just another way of visualizing the main effects. What I like about this dot plot here is that you get each of the data points in there. So we have all 8 specific attractiveness ratings displayed on the plot, with the average here represented by these circles in the middle. Okay, so again, main effect for gender, and then main effect for drinking, right? We're going to average, 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 and then compare them. Okay. Okay, so in order to actually compute the main effects, we're going to create what are called marginal means. Okay, and that's this. These are the means that come from averaging that we've been doing in the on these previous slides. So in the example that we're dealing with, the average attractiveness for men, okay, rating for men, averaging over, right, over the levels of alcohol is called the marginal mean for men. The average attractiveness rating for the 4 pints condition, averaging over gender, is the marginal mean for 4 pints. Now these are just 2 examples. We could do one for 2 pints or none, and we could do one for women and that sort of thing. So you can get any of these marginal means. Okay? But when you hear the term marginal means, know that something has been averaged over. So let's create this table in Stata. And I've done these on the I've done this on the slide, so we don't have to go over into the program. Okay? So here's the table. Okay, what I've got here is the command that we've seen. We saw this portion of it in the previous video. Okay, so I just have shortened what's in the contents of each cell. So now I've got the cell means here, okay, as well as the n for each of these. What I've added is this option down here, this row and column option. What that does is it provides these row means and these column means out here, plus the cell size for each of them. Okay, so let's talk about this 63.75 and what that is. That's the average of 60.62 and 66.88, right? So the average of those 2 things is 63.75. So that's the marginal mean. This one right here is the marginal mean for the no drinking condition. The marginal mean for the 2 pints condition is 64.69. Marginal mean for the 4 pints, excuse me, is 46.56. Then we have the same thing for women and men, right? Here's our marginal mean for women. That's the mean. 60.21 is the average of this one, and this one, right? The average of those three. 56.46 is the average for men, average of those three. Okay? We'll talk about this guy down here in a minute. But so you can see that we have as many marginal means as we have levels of our factors. So there's 3 levels of drink, so we get 3 marginal means. Okay, and we have 2 levels of gender in this example, so we have 2 marginal means. Okay, so let's just answer these questions over here. So what's A1, A2, A3, B1, and B2? So remember, this is our A condition, this is B. So this is A1, A2, A3, this is B1, and B2. Right? So the marginal mean for A1 is this guy. Marginal mean for A2, this one. Marginal mean for A3 is that one. And then B1 and B2. Okay? So if you're just looking at these marginal means, what might you conclude? So I want you to think about that for a minute. You can pause the video and think about what that indicates. Okay, now that you've thought about it, right, what we're seeing is that there is clearly a difference in the number of drinks, right? That as the number of drinks goes up, right, from none to 4, we're seeing a substantial decrease in that attractiveness rating. Okay, so there's a pretty sizable difference there. There's also a smaller difference between men and women, right? They are not nearly as impactful as this. Okay. But notice that's just the marginal mean. We've got this thing going on that seems to be driving everything, and we're going to get to interactions in a little bit. Okay, some notation things for marginal means. So what we've got here is these 3 bits, okay? So remember, J refers to the levels of A, and K refers to the levels of B. So if I write Y bar, right, this thing, this is the mean, and then you see J with a dot after it. So that means that's the marginal mean for A, for the jth level of A, right? Because for A we had the marginal mean for A1, A2, and A3, right? So it's the this would be denoted, like A1 would be denoted as Y bar 1 dot. Okay, the dot means you're averaging over K, right? And this would be Y bar 2 dot and Y bar 3 dot. Okay, when we have the ones for the B factor, in this case gender, remember we have B1 and B2, then we get Y bar dot 1 and Y bar dot 2, and the dot comes first in that case, and that's just a way of saying we've averaged over the levels of J, right? We've averaged over the levels of drink, which is the A factor, and so we get Y dot 1 and then Y dot 2, okay? Then this last one, which is Y dot dot, means we've averaged over both A and B, and that's this thing. That's called the grand mean. The grand mean is what it sounds like, kind of. It's the mean of all means, and it encompasses everything in this instance, okay? So that's what Y dot dot means. There's one more way to denote these things. Sometimes it can be helpful to add just this additional A and B here, just so that you remember that J and K goes with J goes with the A factor, K goes with the B factor, and so sometimes you'll see people, or I will in the textbook, add the A and the B there. But the key principles are the same. You get a dot for the thing you're averaging over. Now that we've got the marginal means established, we can talk about the null hypotheses for the main effects. And what I want you to make sure you can do after you watch this video is make sure you can put these null hypotheses into words. Okay, so we have a 3-level factor of alcohol with 3 marginal means and a 2-level factor with gender. Okay, let's start with gender because that's the easiest one to understand. So the null hypothesis is that the marginal means for gender are equal. So we might say the men versus women marginal means they're the same, or another way of saying that is any difference between men and women, men and women's means is 0. Okay. Now with alcohol, we'd say that all the marginal means are equal to one another. So the marginal mean for 1, 2, and 3 don't differ at all. And so this would be no drinking 2 pints, 4 pints. Okay, the way we write that in terms of differences is in terms of what's called a joint hypothesis. And what you'll see when we actually estimate the factorial ANOVA is that the numerator degrees of freedom for the main effect for alcohol is going to have 2 degrees of freedom. And that's because it's really testing 2 things. And that is there a difference between 1 and 2? And is there a difference between 2 and 3? The null hypothesis being that there's 0. Now, I've written it as 1 and 2 and 2 and 3, but we could also write it as 1 and 2 and 1 and 3. Either one is fine. You really just have to describe 2 of the differences in this joint null hypothesis. And so I just do it this way, and that'll be good. So let's just review here for this alcohol. So the overall way of saying it is that the marginal means are all equal to one another. And the way you describe that in terms of differences is in terms of 2 pairwise differences. 1 to 2, 0 drinks to 2 drinks, 2 drinks to 4 drinks. And that those differences are both equal to 0. So that they jointly both have to be 0 in order for the null to be true. So again, make sure you can put these into words and post any questions you have.